All right. So, this is one of my favorite distributions in probability. What's that one?
It goes back to what you did right there.
It does, doesn't it?
Because I noticed when I got up to 7, the 6 and 7 seem to have the same.
6 and 8, yeah. The 6 and 8,
and then it goes
yeah.
down. I use where I just switch.
Now, watch. Whitney's discovered something I think many of you have as well. We got up to 4. How about 5? How likely is 5?
4.
It's 4 in 36. If you're thinking about percentages, essentially you're adding about 2.8% each time. So it's getting more and more likely. Now, you might ask why it's 4. Because to get a sum of 5, 1 and 4, 4 and 1, 2 and 3, 3 and 2. That's it. There's no doubles in there, so you don't have to count that one extra one. How about 6?
5.
That's 5 in 36, because if there is a double to concern yourself with in there, right? 3 and 3, 2, 4, 4, 2, 1, 5, 5, 1. Boom. Fair enough? Beautiful. 7. 6 and 36. 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. Any die, if you roll anything on this die, there is a face on that die that will make 7 with it. That's the only sum that's true for, right? Now think about what I mean by that. For example, 8. If you want to roll 8, you cannot roll a 1 on your die. Because there's no 7 on the other die. So to roll an 8, how many ways can you do it? It's 5. This is where it turns and starts going back down again. 5 and 36. This is what Whitney was talking about. Those little parallel motion going the other way. How about a 9? Oh, we got really quiet. 4? Count it out. 4 and 5, 5 and 4. 6 and 3, 3 and 6. That's it. You can't roll a 2 and get a 9. You can't roll a 1 and get a 9. Too small. So, it's only 4 and 36 for that one. How about a 10?
3.
Only 3 ways to get a 10. 3 and 36. How about 11? 2, 5, 6, 6, 5. And last but not least, boxcars. It's the same exact likelihood as snake eyes. 1 in 36. But boxcars doesn't have the notoriety the snake eyes does. I don't know why. Because they're just as important in craps as snake eyes is. Does anybody know how the most basic craps bet goes? We'll leave this for right now. We'll come back to it on Wednesday when we play craps. If you want to pass the line bet at craps, Michelle, I take the dice, I pay you $1.
Oh, I just know that 7's good, right?
7's good. Guess what else is good on the first roll?
No.
Well, you know what? 7 is sometimes good. It's sometimes bad, too. Here's the deal. Here's the deal. I bet her $1 to play the game. I roll the dice. I just rolled a 11. That means I win off the bat, because if you roll a 7 or an 11 off the bat, you win. 7 or a Slurpee? Sure, bet a Slurpee. Okay? 7 or 11 off the bat is a good thing. However, what's a bad thing off the bat? Of course, snake eyes. What else is a bad thing off the bat? 12 is actually okay. No, I'm wrong. 12 is bad. 12, snake eyes, and 3. 3, 12, and 2 are bad off the bat. But if you think about it, wait a minute. That doesn't seem like it makes sense, because that means you've got essentially 8 in 36 is the chance you're going to win off the bat. That's pretty good. And there's only a 4 in 36 chance you're going to lose off the bat. That's still pretty good for you, yeah? There's more of a chance of winning than losing. But the other question is, what if you roll a 4, 5, 6, 8, 9, or 10? What if that happens?
Do you keep going?
And this is where it gets genius. So let's say I roll a 8. Just roll an 8. I neither won nor lost right now. I rolled an 8. Now I know that an 8 happens 5 in 36 of the time. Now what I have to do is I have to keep rolling, and in order to win, I have to roll an 8 again. But if I roll a 7, I now lose. And this is where the game is genius. Because as Taryn pointed out, 7 is the most likely outcome. So I'm screwed. I'm more likely to roll a 7 than an 8, aren't I? Just roll a 3, doesn't count, keep going. 9, doesn't count, keep going. 4, doesn't count, keep going.
You're betting on
9, doesn't count, keep going. No, streak. Count it! What is it? Ah, 7. I'm out. So I just lost. I rolled an 8. My job was to roll an 8 before I rolled a 7, but I did not. And that's what makes the game genius. There's like 18 things going on at once. And people are drinking, and they're throwing money down, they're betting against the better. What we're gonna do is on Wednesday, we'll simulate betting pass line with starbursts versus money. And we're gonna see what happens on average over a small period of time and then analyze it mathematically. And see how the house maintains its edge on a game that seems to be favoring the player, at least in certain ways, yes?
So if you roll a 7 or an 11.
Off the bat, you win. You win, like if you bet, it's 2-to-1 payout. So you bet me $1, I give you 2 back if we use
You're
you clear
not
$1.
the people rolling.
You can bet against them too. It gets it, that's
Seems
what,
like a better bet.
there's a whole exam question devoted to that very idea, Tammy. Thank you for that. Tammy brings up a good point. You might want to avoid the very last exam question until we do the thing on Wednesday. Okay, we'll catch you guys then.